look at scale drawings. We learn how to simplify scale ratios and how to determine scale factors. Starter question: where are scale drawings used in real life? So guys, scale drawings represent the size of big things like buildings, land areas, or rooms in a smaller, more manageable size. Architects use them to design houses. Engineers use them to design machines, and map makers use them to show distances. So what we should remember is that scale drawings help people compare lengths, distances, and areas without needing to see the full-size version. We should know the following. Scale drawings are proportional representations of real objects. They maintain the same shape, but are either larger or smaller than the real object. Scale ratios tell us the size relationship between the drawing and the actual object. They are written as drawing length compared to the actual real life length. For example, a scale of 1 centimeter to 4 meters means that 1 centimeter on the drawing represents 4 meters in real life. How do we simplify scale ratios? We'll follow these 3 steps at the bottom. Step 1, convert to the same unit. In our first question, we have centimeters and we have centimeters. Step 2, divide both numbers by the greatest common factor. Now the greatest common factor is 2. So we divide by 2 and we get 1, and we divide by 2 and we get 6. And there is our final answer, 1:6. We have centimeters and we have centimeters. Step 2, divide both numbers by the greatest common factor. Now, 12 doesn't go into 30, but 6 goes into 12 and 6 goes into 30. So we divide by 6 and we get 2, and we divide by 6 and we get 5. There is our simplified ratio. We have centimeters and we have meters. So we have to convert that 5 meters. We need to multiply by 100 and we get 500 centimeters. Our fourth question, we have centimeters and we have kilometers. To get kilometers to meters, we multiply by 1,000, and to convert meters to centimeters, we multiply by 100. And that is 100,000. So we have 100 and 3 zeros. Step 2, divide both numbers by the greatest common factor. 5 goes into 5, 5 goes into 100,000, so we divide by 5 and we get 1, and we divide by 5 and we get 20,000. How do we determine scale factors? A scale factor shows how much bigger or smaller the real life size is compared to the drawing size. So we'll follow these 2 steps at the bottom. Step 1, convert to the same unit. In our first example, we have centimeters and centimeters. Our units are the same, and our scale factor is the second length divided by the first length. 12 divided by 2, 6. So we know our real life size is 6 times bigger than the scale drawing. Step 1, convert to the same unit. We see centimeters and we see centimeters. So that is all good. Scale factor equals 30 divided by the 12. And if I simplify that fraction, I can divide the top by 6 and I get a 5. And I can divide the bottom by 6 and I get a 2. Or you could say 2.5. Our real life size is 2.5 times bigger than the drawing size. Third example, we have centimeters and meters. We need the same unit. Meters to centimeters, we've got to multiply by 100. So we're going to have 500 centimeters. Now for the scale factor, we have 500 over 1. Real life size is 500 times bigger than the drawing size. Our fourth example, we have centimeters and we have kilometers. Now, kilometers to meters, we multiply by 1,000. Then meters to centimeters, we multiply by 100. Gives us 100,000. Now, the scale factor, we divide the second length by the first length. So we have 100,000 We divide that by 5. That will give us 20,000. Real life size is 20,000 times longer than the drawing size. Progress check. Have a go yourself, then check your answers with mine. First question, simplify 8 centimeters to 30 centimeters. So we see the greatest common factor is 2. So we divide by 2 on both sides, and we get 4 is to 15. Below that, determine the scale factor for 8 is to 30 centimeters. For our scale factor, we divide the second measure by the first. And again, we divide by 2 on the top and the bottom, and we have 15 over 4. So the real life size is 15 over 4 times bigger than the drawing size. Second question, 8 centimeters is to 500 meters. Step 1, let's get our units correct. So we have 8. Now we have to convert meters to centimeters. So we will multiply by 100, 5 and 4 zeros. So that gives us 50,000. Now we have to think of the greatest common factor. So we can use our calculators. Does 8 go into 50,000? Yes, it does. So we can divide both sides by 8. 8 divided by 8 is 1. 50,000 divided by 8 is 6,250. And there's our simplified ratio. Next up, the scale factor for 8 is to 500 meters. We have our ratio 8 is to 50,000 centimeters. Now to determine the scale factor, we divide the second length by the first length. And when we do that, we know we will get 6,250. So the real life size is 6,250 times bigger than the drawing size. Next up, we have our green, slightly harder questions. 1.5 millimeters to 6 centimeters. So first, let's convert the centimeters to millimeters. So we've got the 6 multiplied by 10. That will give us 60 millimeters. We see this decimal and it doesn't look so great. So we need to get rid of the decimal. Let's multiply both sides by 2. And on the left, we will get a 3. And on the right, we'll get 120. Now we can simplify. Is there a greatest common factor for 3 and 120? Yes, we divide by 3 and we divide by 3. 1 is to 40. There is our final simplified ratio. Last up, the scale factor. So I can write my ratio 1 is to 40. You divide the second value by the first, and I will get 40. So the real life size is 40 times bigger than the scale drawing size. And that's a wrap. Hey guys, this is Casey at Onetree. If you like the content, please remember to like and subscribe. Also, if you'd like some online tutoring, please email me at onetreemath@gmail.com. Cheers.